So, how many of you know about .com? So, yeah, Brian knows because we talk often. .com is a kind of an entity created by the city of Omaha and Douglas County. In 2002, they decided to consolidate all their IT resources into a single organization. So they created a third entity called .com via interlocal agreement. So to serve their IT services. So basically, we serve the city of Omaha and the Douglas County. Here, we are not revenue generating company. We work for the city and for the Douglas County. So we take care of all their IT needs. That could be implementing a new software, support, maintenance, upgrade, anything related to technology. We do it for the city and the Douglas County. It could be in criminal justice space, public works, health data related, any technology. So every time you interact with any of the local public office, we have behind those IT resources helping them support those systems. So like I said, I'm from .com. I work for .com, and Jim works for me. He's our team lead here. Since last 3-4 years, we've been actively on Amazon. So let's get started. So these are kind of our introduction. So today I'm going to talk a little bit about what .com is. We just talked about it, and what our story is, how we got into Amazon. And then we have, Jimmy has put together a great kind of a case for you, and he's put together a lot of scripts. We're going to talk about a business problem, and we're going to talk about the best practices, how we manage currently our distributed enterprise systems. And then he's going to give you examples of the cloud ready versus the cloud native, the services that we use. And he's got a lot of demos put together for us. And then he's also going to walk you through those cloud formation scripts, how we spin up the infrastructure services using those scripts, and how we've automated all those solutions here. And then at the end of the session, we'll open it up for Q&A. So like I said, .com was created by the city of, via interlocal agreement between the city of Omaha and Douglas County. We support 70 agencies across city and county that are spread across 120 plus locations. We support 5,000 plus applications that work for the city and the county. And we have a massive footprint. We have 500 plus business applications. We have legacy mainframes. We have ERP systems. We have a lot of custom applications. We are primarily a Java shop. We run Salesforce. We have right from our Stone Age legacy systems to cut bleeding edge technology. You name it, we run it on our shop. You will find some use of it at our place. So, and I'm gonna turn it over to Jimmy here. He wants to get started here. So, come on, Jimmy.
Thank you.
Take it over.
So, my name is Jim Dolinski. Like Vijay said, I'm the team lead at Douglas Omaha Technology Commission. I've been there a long time, very long time, even before it was Douglas Omaha Technology Commission. So, I have a lot of experience in that area. So, it was nice to hear some of you guys, and this being your first meetup, it sounds like we've got a pretty wide audience as far as skills, some entry, and we've got some very advanced users in here, so this is good. Anybody from the UNO Masters program in here? No? None of the students came? Okay. That's all right. So let's get started. So back in 2012, I started kind of the AWS journey, getting familiar with it, mainly kind of on my own. This was pre.com. And what I seen was this. And what I did was this. So I'm sure a lot of you guys have had a similar experience with Amazon. Amazon releases services just about as fast as you think you finally figured out what one actually does. So it's an ongoing process. It's something that you'll probably never master just with the amount of pace and the delivery that they have. And sometimes I still feel like that. So what I'm going to take you through is kind of a DevSecOps. I know we talked a little bit about DevOps. Does everybody know what DevOps is in here? Yeah?
Does everybody, you look for the negative responses. Does everybody not know what it is?
Okay. All right. So I won't.
Please clarify.
All right. So let's just talk about DevOps in general. DevOps in general is borrowing the practices that developers have used, creating software and implementing those practices into operations. So that means source control, versioning your software, building servers with scripts, making everything automated and repeatable, and practicing an immutable infrastructure. So you're able to kind of build a server from scratch. And I'll talk a little bit more about that as we get further into the demo. Well, this is the dev side, and this is where I live. I've been a Java developer, well, primarily more Groovy than Java, for the past 10 plus years. And this is really where I kind of started, that Java stack. We have 4 primary areas within the development space. We have Java, and then about 2014 is kind of when VJ came into the organization and began a transformation. And one of the things that he asked me to do was take over the PHP side, or at least help them guys. We had 2 teams. We had a Java team and a PHP team, and they were in completely different paths. Yeah, we were the same team, but we were doing totally different things. So as you look down these columns, you'll see consistency. And that was one of the first things that we wanted to do between all of the teams, was use consistency. They didn't use source control. They basically got onto the server, production server, VI, rename files. I mean, it was crazy. So we've done a lot in that area. That's the area we'll focus on today, just because it's pretty simple. But then as we kind of got into the whole cloud realm, especially with serverless, we've been doing a lot with Python and a lot with Angular. Anybody doing any Python or Angular? Cool. Very, very great technologies to run on their serverless architectures. We put our Angular stuff on S3, hosted as a website on a bucket, and then our Python stuff is all Lambda-based, Lambda functions. So you'll see that. So core source control, we all use Git, and then the dependency management we don't really too much care about in the AWS space, but databases, all the databases we use, we try and use RDS. When we do pick a platform or a technology on AWS, we try and pick a service, because we want to focus on the customer's needs as opposed to, keeping servers running, because they don't care what version of the OS is on there. They don't care what version of the database is on there. They want business value. And that's what AWS has provided us, is to kind of take a step back and forget about those infrastructure technologies that are running. I primarily work with Linux. So you'll see Linux within the demo. AWS works great with Windows. Nothing wrong with Windows. And then also I mentioned the Lambda and the S3. So on the security side, one of the things that I'm very passionate about is security. I'm also CIS certified, and we've implemented a lot of security best practices within the organization, in particular this development area. We no longer allow direct server access for the developers. Previously, they were able to get on the servers and do stuff. You won't see this today, but we ship all of our logs to a central location and use Elasticsearch. If you've ever heard of that, it's very similar to Splunk, so that the developers can get on there and that's where they search their logs. We also no longer allow SSH access at all into any of our servers, and I'll show you how that's done. Access control. So we'll see our business problem that we're going to talk about in a little bit. We're using the service catalog, AWS's service catalog. Configuration and compliance, we're using AWS config with systems manager. The WAF, we are using Shield. Everybody gets Shield out of the box. Layer 3 and 4, DDoS protection. Advanced Shield is layer 7. We are not paying for that at this time. We have a third-party WAF solution for that. Auditing, we use Inspector, AWS Inspector for auditing. Elasticsearch, we've got some auditing built in there. In addition, we also use a third-party tool for audit or for security scans as well. So that's kind of in a nutshell at a high level our security tools. The operation tools that we use for deployments are Java stacks. We do run some on Beanstalk. We use Code Pipeline. The PHP stuff is all AWS Code Deploy, Code Pipeline, basically across the whole board. And again, the consistency between the areas. And that's so that as we bring resources in, they're not totally, confused by moving around between the different technologies. We want to be able to take a Java developer who maybe has an interest in Angular or has an interest in Python or has an interest in PHP and not have to worry about all these tool sets. So you'll see that quite a bit throughout this. Infrastructure as code. We're using CloudFormation and Systems Manager. We've also used Terraform and Chef in the past and still have some Terraform and Chef. We use Git for our versioning control system of all of our infrastructure code. Alarms, CloudWatch, it's out of the box with AWS, great tool. SNS, simple notification service, also AWS. Everything I'm going to talk about is going to be AWS based. We do use some other tools as well. CloudWatch dashboards. The patching, we use Systems Manager. If you have not used Systems Manager, that's probably one of the most exciting features that I've seen come out of reInvent is the announcement. It's always been there. It's just been buried down into the EC2 console at the very bottom of the left-hand page. Now they've actually given it its own dashboard. It's becoming a first-class citizen. So it's really a great tool. If you haven't played with it, there's 7 components. We'll go through them briefly. And then also Service Catalog. We'll talk a little bit why we like Service Catalog. So today's focus is going to be on that PHP stack. And we're going to talk about some of the development, security, and operations areas. So here's our fictitious business requirement. So we want to know the company's technical inventory. So we want to have a CMDB. We want to know what's running. How many times you've been in a shop and there's, they don't know what they have running in their infrastructure. We want to have full control of what's in the environment and be able to tell at any time, are we vulnerable to a specific patch on a certain platform? That's very important to us. Cost transparency. Our customers within the city and the county want to know their costs. We used to give them a big bill, and they said, what's behind this big bill? And so with AWS, specifically tagging and breaking accounts down, you have that cost transparency, and you can show exactly what their spend is. Increase customer value delivery. I talked about that. Use higher level services when you can. Don't spin up an EC2 server and put MySQL on it. Try and use the higher level services. They're there for your benefit so that you can deliver customer value faster. Prod and non-prod parity. This is kind of where that DevOps space comes into place. So many times that I've been at work, and how many of you have heard, well, it works on my machine, or it works in test? Yeah, that's Dev and our prod and non-prod parity. Use services and automation to reduce maintenance and errors. We talked about that. And really, how do you manage your growing AWS footprint? When we first started, single account, and it was managed by 2 developers. So this business case at the bottom is kind of close to heart because it's actually a true business case. So your company's AWS footprint and usage is growing beyond a single business unit account that was easily managed by a small team of 2. So how do you tackle that problem? That's a big problem. So one approach, we can hire 2 people for every business unit account that we are going to provision. DJ, is that possible? No. How about 1? No. 1 person. All right, no. So we've still got those 2 people who manage that 1 account, but we got to make them more productive. And with some of the tools within AWS, you can do that. So as your footprint grows, how do you manage? 5 areas we'll kind of talk about today. Has anybody used AWS Organizations? Okay. Or AWS Organizations is pretty cool. It allows you to have a top-level account and a bunch of accounts under that. You can quickly spin up new accounts and be able to track spin within that top account. So I'll talk about that a little bit more in depth a little bit later in the slide. Security and management, we'll see a little bit on inspector and guard duty. Guard duty is a new service that's been released. You get 30 days free right now, so go ahead and check it out. One of the toughest things about, I think, this whole demo is all the icons. You guys ever have problems trying to figure out what these icons are? Yeah. Yeah. So that's actually AWS Shield, and I mentioned we're using just the default Shield, which is just layer 4 and 5 DDoS protection. Governance and compliance, so you're going to see service catalog, systems manager, and AWS config, and then configuration management, cloud formation, and systems manager. So here's AWS organizations, and this is best practices according to some AWS white papers. What you generally want to do is you want to create your top level account as your billing account. That's where everything rolls up to. And then as you spin up new accounts under that, a lot of people spin them up either by business unit. So my business unit is web, so we've got a web account. You may spin it up by domain, maybe some specific domain that a particular customer has. Shared services, so this could be where your VPNs and your IPsec tunnels, your direct connects are used. And then compliance accounts. So with us being government, we have a lot of applications that are need to be CJIS compliant, as well as we have applications that have personal health data, so we have HIPAA related compliance that we have to meet. So we have compliance accounts that we have to do. And then what we do is all of these accounts, we ship all of the log files, all of the CloudTrail, all the flow logs to a security account that is centrally managing those logs. Those logs are hashed so that you know if they were ever changed, so that if we were ever in a legal situation, we would have a true copy of all the logs that has been locked down to only a few privileged users that can access them.
Jim, you mentioned HIPAA and CJIS. Are you subject or concerned with any other compliance regimes, IR6 and any others you know?
Yeah. PCI is another one. There are several. The big focus for us now, we just launched our HIPAA environment. That's up and running. CJIS is next. We're going to be putting that into the GovCloud, and then we're going to tackle the other ones as we get down that road. So, good question. All right, so one of the most powerful features in AWS is tagging. Tag your information technology. There's a good link here that describes best practices for AWS tagging. Tagging allows you to see resources very quickly on the console. It also allows you to be able to see your cost allocation based upon certain tags, multiple tags. You can really get granular and show what a particular department's cost is for a particular application. Also, automation is based upon tags quite a bit, actually all over the place, especially within Systems Manager. And then also, you can control access control with the tags that within AWS. One of the challenges, though, is keeping your tags and keeping that convention across all of your services. That was a challenge that we had. We'll kind of show you how we solved that in a little bit. So configuration manager. How many of you been in a shop and you just started and you're talking to your peer and they tell you, don't touch that server. Don't walk by that server. Don't sneeze on that server because if it reboots, we don't know what to do, right? So those are snowflake servers, right? And we've all heard that term. We want to practice immutability. We want to be able to take a server from a base image, configure it with scripts, and be able to repeat that over and over and over again so that it's in the same state every single time. That's the true essence of DevOps. We do that for, so we got resource provisioning. So there's two pieces of DevOps. There's the resource provisioning piece, that's spinning the boxes up, and then there's the configuration of the boxes. So the configuration piece, we do OS hardening. We We comply with the CIS benchmarks, Center for Internet Security benchmarks, and we also do the software installs, and I'll show you a quick example on that. So one of the kind of the things that rang out every time I went to a session. So anybody attend reInvent last November 1? Was their kind of tagline that year was treat servers as cattle and not pets. So tear them up, tear them down, you know. So configuration management. So this is Systems Manager. There are 7 components to that. There's the run commands. This is basically being able to execute a command on the server and be able to get the response. It's tracked within Systems Manager logs, so you don't have to have your Bastion host do a bunch of logging, and you know what's being done on your servers. In order to use your Bastion host, you have to do some extra stuff to make sure you have all of that trail of activity that happens. Also, state management. So that's keeping your resources in a known state. That's what state management is. Inventory management. This is very big for us. Being able to know what packages are running on which servers and what servers are in your inventory. You know, just what resources are you using? What's the spend on those resources? Maintenance windows. We all know what maintenance windows are. They allow you to create maintenance windows. You create targets, and then you create tasks. And we'll see an example of that. Patch management is a good thing to do in a maintenance window, but you can also apply patch baseline policies so that as the severity of the patch comes out, you can classify and say any patches that come out by a vendor that they classify as severe and their security, roll them out within 0 days on non-prod and then 1 day on prod. So you can create these really customized rules within patch baselines for your patching policies. Automation is doing a series of steps. So maybe you want to build an image that will be used within some type of infrastructure. So for tonight, we're going to build an image for a PHP infrastructure. And what you want to do is you want to start with the base image, and you want to configure that image with scripts so that it's, again, repeatable. So parameter store, this is a really cool thing. This is very similar to HashiCorp's Vault, Spring's Vault. This is basically a key value pair that you can ingest within your scripts. It's very tightly tied to KMS, the key management services, so that you can also encrypt these values as well. So there's 3 key documents within Systems Manager. One is policies, one's commands, and one is automation, and we'll see those. And then the tip here, I kind of briefly mentioned that you can get rid of your Bastion infrastructure, and close your SSH and RDP ports and reduce your attack surface by using Systems Manager. Governance and compliance. So service catalog, this was one of the big reasons why we've kind of been doing more cloud formation. So it's the ability to allow basically operations or template authors to build these templates and be able to provision them out to different teams so that they can create their own stacks. We don't want just anybody being able to provision resources out there in the AWS infrastructure. We want to kind of control that. Service catalog is a great way to do that, and also to see what is provisioned. So we'll see an example of that. It also helps the employees quickly find what you can provision within your infrastructure by what templates that you put into the library. You can centrally manage the IT lifecycle, and you basically create approved portfolios for use within your organization. Config is really cool, and I've got a kind of funny story about that I'll tell you in a bit, but config is a continuous monitoring and assessment tool. And so out of the box, AWS has a lot of config rules that you can use. You don't have to write them yourself. They're really good rules to start with. For instance, when we see some of the rules that were wrote and launched via Cloud Formation, you'll see a lot of red marks, and it's these rules that are firing and detecting that. So if you want to make sure that CloudTrail is turned on in your environment, create a config rule that says automatically check that CloudTrail's turned on and run that on an interval so that we can know that CloudTrail's turned on. It also allows you change management and history. We'll see an example of that as well. All right, so security management. Inspector. Inspector is AWS's built-in security scanning engine. They have 4 rule packages that they implement that you can use: common vulnerabilities and exploits, the CIS/OS benchmarks, security best practices, and runtime behavior templates. You can package all of those and run an inspector report, and it'll give you a report on how your compliance is of your infrastructure. Guard duty is continuous monitoring for malicious or unauthorized behavior. So it'll detect potentially compromised instances and any reconnaissance that might be happening by attackers. It's a little bit different than Macy. It's a new service, so I'm not quite as familiar with this one as some of the other ones, but it's something cool to check out because you get 30 days free. So if you haven't, go ahead and spin that up. And then Shield, that's just the standard DDoS. So before I get into this, I want to talk a little bit about cloud ready versus cloud native, because when we started our journey, we did a forklift. And if you do a forklift into the cloud environment, you don't get the true benefits of being in the cloud, right? You want to pay for what you use. You just don't want to forklift the stuff up there. So one of the things that you want to do is make sure that your application code is stateless. That's one of the biggest things that we keep running into, is when you build your application stateful, tie it to a particular file system, then as servers spin up and as servers spin down, you lose that state, and it's a bad experience for your users. And then what you have to end up doing is doing sticky sessions, which beats the whole purpose of having, cloud infrastructure that scales. Cloud native, we're doing more and more of that. This is the serverless application model. That's primarily with Angular. And shout out to Ali. That's our Angular guy over there right now. I see he made it. Thank you. So we're doing more and more of that. Just a general unwritten rule. Legacy code using modern frameworks will typically migrate to a cloud-ready architecture easier. If you're not dealing with an application that's using some type of modern framework, it's sometimes very difficult to make that cloud ready and take advantage of the horizontal scaling within the cloud. Any questions so far? Go ahead and shout out anything if you do. So we've all seen this. This is the cloud architecture, 12 factors. I'm going to just skip this for now. You can look at that. So what we're going to get started with is basically everything that's checked in this box that will be in this demo. And demos are good and bad. And I kind of debated whether I wanted to do a live demo, and BJ's like, record it. And I'm like, no, I want to do a live demo. And sometimes I think our QA folks, all they do is they demo to each other to test the application, because that's usually when it breaks, right? So what we're going to do is we're going to do some live demos. I've got, it looks like, 14 scripts we're going to run. And I'll try and debug them. If I do get stuck on something, I told VJ I have a fallback. I've already provisioned the environment in another account, so don't worry about it. All of this code is up on GitHub. So you missed the GitHub, but it's just GitHub, Dolinski, and then you'll see the code out there. There is some bugs in it. Maybe we'll patch one and we'll see how the pipeline works. So, oops. All right, so the first thing that we're going to do, does anybody ever visit AWS Labs? AWS Labs is by far one of the best resources that you can go to when you have a problem that you're trying to solve and you're scratching your head. How do I do that? AWS Labs is a collection of repositories in GitHub that AWS engineers put together for us to consume to solve problems. This very first issue that we had was, how do we get our infrastructure code from our source repository built and deployed out to maybe an S3 bucket so that we can utilize it? We don't want our staff to make out-of-band changes. We want them only to change what's in source control, and we want to have that audit trail. So that's what we're going to demo first. So let's do that. So So this is a brand spanking new account. And the first thing that I need to do is I need to go to IAM. And I probably should have set this up. So one thing that you'll want to do is this particular demo is going to be using code commit, and we don't use code commit on the developer side. But what we found is that the operations people or the systems administrators tend to adopt things more when it's built into the same product. So all the ops code lives in code commit, and what you need to do, let me get this real quick. Just get I got a key pair here. I should have already put this in here. So AWS code commit does not use your IAM credentials for authenticating against code commit. It's either a separate account that you provision or you just upload an SSH key like I did. So I just put my public key up there so I don't have to log in. So the next thing that we're going to do is we're going to go over to Cloud Formation and we're going to create a stack. And for now, we're just going to upload a stack. And I'll use what I put into GitHub. So the first stack that we're going to create is this pipeline stack. There it is. So I tried to break, when you look in GitHub, there's basically 3 portfolios, which is portfolios are what our service catalog uses to group related products, and within portfolios are products. So I'm going to run this pipeline stack.
Hey Jim, I'm curious, are these stacks things that you guys are using in your current service catalog, or are they just for this lab?
They are in the service catalog, and you'll see that in a bit. So we're going to call this, what was I calling it? Pipeline to service catalog. Good. And then the repo, I'll just call it demo. Does anybody use Cloud Formation? One person? Okay.
I have a question.
Do you
The components that you showed, or the demo you showed, all these components are available in the free version, or are new to this AWS?
Okay, good question. So yes, Cloud Formation is free, but you're charged for the resources that you provision. So we'll do next, and then we'll do some acknowledgement, and then we'll talk about what it's going to do. One of the newer features of AWS Cloud Formation that was introduced, not recently, but it's been a while, was the ability to see what's going to happen in your environment. So we kind of went with that because it was really, really nice to see what changes are happening. Terraform does it out of the box. AWS is finally catching up with Terraform on that front. So now we see the stacks in progress. So if we watch the events, it's starting to create a code commit repository. It's going to create an S3 bucket. Let me go back to the slides while that thing's running. So here's what's going to happen. It's going to create a code pipeline. It's going to create a Git repo. It's going to create, so these are the template offerers. This is actually off the blog. They're going to create templates. They're going to put them into a mapping file within that thing, within the code that I just showed. It's going to create a code commit. It's going to create a code build. It's going to create Cloud Formation, and it's going to create a provision, a Lambda script that will build and deploy and synchronize all of our templates into the service catalog. And so this Lambda function will synchronize the templates into an S3 bucket that will be made available via the service catalog. The mapping.yaml file is kind of the configuration file that is used within this project. It contains, and I can show you that real quick. It contains the information or the metadata about your service catalog. So this particular portfolio, so I broke it into 3 portfolios: Dev, Operations, and Security. This is Security, and this contains all of the security-related products, just to keep it simple. And then underneath the products, those are all the products that is going to be within this particular portfolio. The accounts, which I think I've got a bug already. So you want to put your account here. So this is going to probably, let's go back to, let's see if this, it did complete. Okay. Whew. The accounts are, you can share within the service catalog. You can list multiple accounts, and so if you have a HIPAA account, you have a web account, you have just a different business domain account, you can share that service catalog across accounts and across teams. So it provisioned, yay. So there's the output, and let's just verify that we can connect to our repo. Copy. So I'm going to do a VCS. I'm going to check out from version control. I'm just going to check out the blank repository. Okay. And then I'll just check that out to my desktop. And then we'll clone it. Could not read from the remote repository. This is why live demos are dangerous. Okay, so the repo's created. I'm going to go back into IAM. I'm going to go back into my user. Don't worry if you, I will be tearing this down after the demo, so. I'm not going to debug my. All right, so let's try and clone that again. So let's go back to our stack. Let's go to the outputs. And this time we'll use the HTTPS URL. And we'll check it out. Version 1 repos. Okay, we're going to go to plan B. So, this is the account that I did provision and I set up that contains all of the scripts that are run. So here's the pipeline to service catalog. And within this, what it's going to do is it creates basically the code pipeline for AWS and allows you to commit code to code commit, runs it through the build pipeline, and then pushes it out to an S3 bucket so that you can use it. What it's ultimately doing, which we should see if I can connect, is the service catalog. And here's what the service catalog looks like. So when that runs, you'll get 3 portfolios: security, development, and operations. And within each one of those portfolios, you'll have products. And these are the products that are allowed to be provisioned by your staff. So you're basically building the templates that your staff or different teams can use. So you're centrally controlling them. You can limit them by tags. You can limit them by policy, etc. So that is step 1 of the process. So the next step is shared storage. And shared storage is nothing more than 2 buckets, 2 S3 buckets that contain application code and Lambda code. And those 2 buckets are used by our CI/CD pipelines. We don't use code pipeline for development. We are a Jenkins shop. So when we push out new code, it's done through Jenkins, and it's pushed to one of those 2 buckets. And that's usually done by your CI system. You can use any CI system that you want. And so that looks like this. So the shared code storage is here, and it creates 2 buckets, and you can see all of the resources. So let's go to, it's in the operations portfolio. Let's go to S3. And then you'll see the 2 buckets that were provisioned, the app bucket and the Lambda bucket. Now, if you do check out the code from the repo, there's 2 things that you're going to have to do manually. One is there's a Lambda function that's going to be used further in the demo to be able to dynamically identify unused CIDR blocks within your VPC. So basically, it's a Lambda function that'll go out to your VPC and use a DynamoDB table that will check to see what are unused /24 blocks that you can use so that you can dynamically spin up new environments and not have to go into the console and see which subnets are being used and which subnets are not being used. It's all dynamically captured and spun up. So the other thing that you have to do is, for this demo, there's an app bucket. And this app bucket, so I mentioned we have Joomla, we have PHP, but we run a content management system. And that content management system that we run is Joomla. And so I've taken the latest stable package from their repo, and I put it into this bucket. And what we're going to do is we're going to deploy that out to our infrastructure using code deploy.
Jim, every time you want to deploy a new application, you deploy this entire stack, a new PHP application, this whole set.
No, you just deploy the application. You just deploy the application.
So there's a PHP bucket for each app instance, though. Is that, or sorry, a bucket for the app for each instance, or for the entire enterprise?
Entire enterprise.
Okay.
Yep. They're prefixed, and each app will live in its own subdirectory, so to speak. It's object storage. But so yeah, that is for the enterprise. So that's a very simple CloudFormation script that does the provisioning for the buckets for storage. So the next thing is the VPC. And this is, again, a one-time shot for your account. Maybe you want to have a couple of VPCs within your account. But what this script will build is the VPC. It'll give you the internet gateways. It'll give you 2 NAT gateways and some routing tables. And there's 2 public subnets within it. One tip that we've kind of learned through the process is when you want to use your stack across regions is to go ahead and set up a hosted private zone for your VPCs. That way you can reference the same domain name across different regions. And they'll be pointing to different endpoints. But to AWS internally, they'll resolve to the right place because they're a private hosted zone. So the next stack will do that, or the next template. And let's take a look at that VPC. I'll jump into the service catalog since we haven't seen that yet. Wrong account. So here's the service catalog, operations, and let me switch to the new look because I'm in incognito and I'm not as familiar with this. Okay, so basically at the top here you have all the products that are able to be provisioned across your enterprise, and then you have all the products that have been provisioned within your enterprise, and you can provision things multiple times. As an admin, you can define products, you can define portfolios, and here's where some of the power of tagging comes in. One of the things that we ran into a lot was missing tags. And when you have missing tags, you have incomplete data and you're not getting a true picture of the environment. What you can do with Service Catalog is when you go to provision a particular stack, you can say, these are the tag options that go along with that stack. And so I'll show you how to do that towards the end, but that way when the stack is provisioned, you're guaranteed to have all of the tags that your infrastructure requires for cost reports, for automation, for just any kind of purpose. Tagging is extremely powerful. I can't mention that enough. So if we go back to the standard CloudFormation console, let's go ahead and let's look at our so we've done the pipeline. The pipeline will build and deploy a Lambda function that will sync to the catalog. The storage is just a shared bucket across the enterprise for app code. And then now we've got the network VPC. So within the network VPC, these are all events that happen, but this is the outputs. Now, one of the things that I'm doing within these CloudFormation scripts is I'm using cross-stack references. Because a lot of times what you want to do is you want to have input from one stack, or the output from one stack as input into another. And you can do that with cross-stack references, or you can use nested stacks. I tend to prefer cross-stack references, and so what you do is, let's look real quick at the CloudFormation script for the VPC. So here's what a CloudFormation script looks like. And it takes some parameters, so it asks you for a CIDR block /16, and then it asks you for 2/24s for your NAT instances. And then it builds the VPC, the internet gateway, it attaches the gateway to the VPC, builds the subnets, does all this stuff. There's our hosted zone to share, and then it does these outputs. This right here is what's called a cross-stack reference. So that way I can use that output as input to another stacks. That makes your stacks and your templates more portable across regions and across the same account within the VPC. So I could essentially run this VPC within the same account, have no conflicts whatsoever, as long as I don't pick overlapping CIDR blocks for that /16 and the public subnets. So same with the web infrastructure. Yes?
This is the first time we are seeing the YAML. I think what we read is like YAML is for configuration files, but why do you use YAML over here instead of some other?
Okay. So CloudFormation allows you, that's a good question, to use two different ways to provision your templates. One is through YAML, one is through JSON. If you've used AWS quite a bit, they're very heavy on JSON. All your policies, all your security is JSON. CloudFormation has recently announced support for YAML on Systems Manager. The support has been there for a while for CloudFormation. It's really just a preference. I prefer YAML. YAML, you can have comments, and I think it's more concise and more easily readable. So,
Joe,
yeah.
When you're building these scripts, it seems like there's a lot of room for error. Is there a way to test these before you deploy?
There is. So one of the things that DevOps is, one of the best practices that you should do with DevOps is write test scripts. I didn't write them for these. So basically what you'll do is you'll start up a script, you'll run some tests against your template, and then it'll tear it down. I didn't have time to build that, but yeah, that's a good question. You should build test cases even for your infrastructure code. Any other
Are you
questions?
testing those on like you run the provisioning script and then run a test to go see what it provisioned? That's
Yeah.
the test you would write?
So you'll want to do it within your pipeline, right? So there's a tool called, we do several things. Have you all heard of linting?
Yeah.
Okay. So there's a tool called CloudFormation NAG, which is basically a linter for your CloudFormation scripts. And what it'll do is it'll go out there and check your syntax and check some stuff on your CloudFormation script just to make sure it conforms to certain things. If it passes that, then you want to start pushing it into your unit testing where you're actually provisioning the stack and then bringing in more resources to test that stack. So the stack's got to be up in order to test it, but as part of that test process, the last step is to tear it down. And you'll kind of see something like that in the automation, but it's a totally different use case. So good question. All right, so we've got our VPC built. The next thing is this auto subnet. We talked about this a little bit already. So auto subnet is kind of like a utility that we have that will go out to your VPC and check for unused CIDR block ranges, /24s. And so if I go into my account and I go into Dynamo, there should be a table in here. There it is. Service catalog that has all of the CIDR blocks that we're using within our VPC. So this Dynamo table keeps track of it. The Lambda script goes out when you launch a stack and says, what CIDR blocks /24s can I have that aren't being used? And then it just gives them to you. Now you don't have to go out to your console and try and figure out. Because once you start getting a lot of subnets, very, very, very difficult to see what CIDR ranges are open. So just a quick way to get an overview.
In your formation of a VPC, you basically go and after a DynamoDB table and enter the CIDR block that your configuration have used. At what time you read it into DynamoDB table?
Good question. So on the provisioning, on the parameters for the VPC, we give it a /16 and we give it 2 /24s for public subnets, right? So right now, the Dynamo table is going to go, it doesn't have anything, any awareness of those yet. It's once we start provisioning. These subnets or these CIDR blocks are coming from the web infrastructure stack that we'll provision here in a little bit. So once I spin up the web infrastructure stack, it's going to want 2 private subnets and 2 public subnets. And then what it's going to do is it's going to go out to DynamoDB and say, hey, I need 4 /24 blocks, give me next what's available. And then when you tear it down, the same Lambda script will remove them from Dynamo. So you always have a kind of an idea of what IP ranges are available within your environment.
As an architecture design principle for you guys, you'll mix applications in a single VPC, but not in the same subnet? That's sort of what you do?
Depends. Yeah, it all depends on the use case. So.
And none of your apps live in public subnets because you don't
No.
provide public access anywhere, right?
Nothing is in public subnets, and in fact, we are removing all of our Bastion hosts. So the only thing that's in our public subnets is our ELBs and our NAT gateways. So. All right. So that's pretty simple. All right, so this is the automation script, and I'm actually going to run this one. So we're going to take a base AMI, and I just got the latest AMI out of the community marketplace, and it's an Amazon Linux. And then we'll go ahead and we'll run this, and then we'll take a break. But what it does is it's going to build the AMI for PHP.
Can you please clarify what an AMI is?
Amazon Machine Image. It's a virtual image. So sorry. It'll build this virtual image, and it's going to bootstrap it with everything that we need for our application. So it's going to install Systems Manager agent. It's going to install the Code Deploy agent. It's going to remove. This is funny because I get the latest AMI from the community marketplace, and it's got PHP 5.3, which is like really, really old. So it's going to remove those packages. It's going to install PHP 7, install the latest Apache server, and do some other stuff. So let's do that real quick, and then we'll take our break. All right, so for this, you have to write a document, and this is within Systems Manager. So I'm going to go into Systems Manager, and I'm going to go into Automation, and the CloudFormation script that we wrote will provision this. Maintenance Windows Stack Manager. Nope, I want Documents, sorry. And Document Type, Automation. So the CloudFormation script, this is provisioned by Service Catalog. The way you can tell is it gives you this crazy name, and it's PHP 7.0 config. So I'm going to select that, and I'm going to go ahead and build this. Actions, create new version, members, run command. Document name, prefix. Trying to remember where I put it. All right, so it will take the source AMI, which will be the Amazon machine image, and it'll give it a target name, and it's just going to give it a target name based upon this convention, PHP 7.0 Linux, source ID of the AMI, and then the date that it was created, and then the instance type to spin up. So let's take our 10-minute break now. I'm going to kick this off so that we can come back to it and see the results. So, or 15-minute break. So I couldn't check out because my config file was pointing to the wrong user. So it's always good to have a good backup, and it's probably a good thing that happened because I would have never got through all this content. I'm still going to kind of burn through it. Yeah, that's my issue right here. Wrong user for the account, for the SSH key. So, all right. So while you guys were away, I did kick off the automation script that's going to build the AMI for the PHP that we're going to use. And basically what it is, it's an automation document with Systems Manager. And the way it works is it launches an instance. So it launches an instance, the size you specify with an input parameter. The second step that it does is it removes PHP. It's running like 5.3, even though it's the latest AMI. It also removes SSH. So I have no SSH running on this box. And that's because we're going to use Systems Manager in order to access it. It also installs PHP 7.0 and Apache 2.4, which is the latest version. PHP is a little bit older, but I didn't want to get too daring. It installs the code deploy agent, starts up HTTPD, stops the instance. Now this is very important. You should never take a snapshot of a running instance because at the moment that you take that snapshot, there could be sensitive information on that. You should always stop, come down clean, and then take your AMI. So what happens here is it stops the instance, takes the snapshot, creates the AMI, and then terminates the instance. This is an automation document. That's an example. So.
Jim, can you show us where the script is or the scripts are behind this?
Yeah. So it would be under the portfolio development, PHP 7.0 configuration. These are all resource types defined in CloudFormation. And we're telling it this is a document. These are the parameters that it takes. So it takes a source Amazon machine image, a target, and then what it renames it to, and then the instance type that you want to launch in order to run all these commands. You may not want a micro. And then what it does is it executes a series of steps, and here's where it starts. There's the main steps, and what it does is it launches the instance, and this is just a list. So YAML notation for list is a dash. So it launches the instance, it does some curl, it identifies if what region it's running in, and then it also installs the SSM agent on that particular instance so that we can do some of our commands. That's all in the user data. The next step, it removes HTTP and PHP, and these are just standard Linux commands. So the run command within Systems Manager lets you use all of the tools that you're familiar with as an administrator. PowerShell, Yum, apt-get, whatever you do, Bash or PowerShell, you can do within Systems Manager, which is kind of why we're moving away from Chef. The learning curve is so much less. Previously, we did this through Chef.
Question for you on you're removing all the access like SSH and just go to Systems Manager.
Correct.
You know, from time to time we find ourselves having to troubleshoot unknown issues, like for example, the latest version of TimeSync has a bug in it, and it's, you know, all of a sudden your time's out of sync and you got to figure out why. What do you do in those cases?
You run the run command. You can query your inventory. I will show you that. For me, that was also a challenge because I'm so used to just shelling onto the box and, you know, running the commands. And it's been a transformation that's been not difficult, but it's been learning for me to get away from the command line and start to use Systems Manager, because Systems Manager will log anything and everything as far as access. If you have a Bastion host, you have to install some additional software in order to know, and you got to control access. And so it's an additional attack surface, plus you have to control user access to it. We still use Bastion boxes. I don't say that they're completely gone, but if you can, try and just terminate the SSH and get rid of the jump box.
Do you find yourself putting on SSH at any point?
No, I haven't on the stuff that we've done. You know, I've like, oh, I wish I just had it, but you know, I'll show you how you can do like some run commands and stuff and do the inventory. So here's where you remove, and so it's just steps: executing Yum commands, executing Yum command. This is putting on the latest code deploy agent. So this is doing a wget out to an Amazon URL. We're changing some permissions on the file and then executing the install script and yada, yada, yada. So then it starts, it tears it down, and it's just all in a series of steps.
Yeah, did you create the whole script from the scratch, or something that is available, or some skeleton is available, you just plug in some of the parameters?
Yeah, so it's a combination of both. So what I did was I used the CloudFormation document resource type, and there's 3 types of documents: automation, policy, and run. And so what I did is used this document type as an automation document, and gives you the skeleton, but you got to fill in all the blanks. So, good question. All right, so let's go back. It's completed. So now if we go over to our EC2 console, the instance is terminated, and we go to the AMIs, we should see one for today. This is the latest one. And we see multiple ones today because I have this running on a script, but this is the one that we just created. So now we have a golden copy. And one of the things that I was going to do, trying to do, ran out of time, is to implement parameter store. So with parameter store, you can create your latest AMI for the region and just suck that in from the parameter store, which is really powerful, because if you look at CloudFormation scripts, a lot of people hard code all the AMIs for all the different regions. You don't have to do that no more. Use parameter store, suck it in, and have a Lambda script after your maintenance cycle executes, patches it, and does all its work, put that AMI into the value for that parameter. So you can automate that complete cycle.
Is Lambda HIPAA compliant?
Yes, Lambda is HIPAA compliant, I believe, yes.
Yes.
They're adding more and more services. You really need to check. Off the top of my head, I believe it is, but before you use it, double check. So. All right, so let's go back to slides. So that was the PHP conversion or configuration for the AMI. Now the website infrastructure, and then we'll start getting going a little bit quicker. So this is going to provision a complete stack to deploy websites to. we're going to deploy, in our infrastructure, we deploy multiple websites to this infrastructure. And so what we have that's going to get built by it is we're going to create network access control lists for each private and public subnet. So we're in 2 AZs, which is best practice by Amazon. We're going to create an elastic load balancer in both public subnets. We're going to create auto-scaling groups, so it's basically a 3-tier architecture in both private subnets. We're going to use Amazon EFS. Now, where this is useful in our use case is content management systems will share files. You can't mount EBS volumes across instances. EFS allows you to mount shared network attached storage to multiple instances. And so we've done quite a bit of R&D on this stuff, and we've used EBS for our websites, and we've built the code within the AMIs, and then we've also run it on EFS. We may go back to the AMIs now that we're doing some more and more automation, because running on EFS, you'll take a performance hit. Trust me, you will take a performance hit. And it's all built upon burst credits. And sometimes what Amazon recommends is just for you to put extra data out in your EFS directory so that you get higher burst rate. And then we're using Aurora for the RDS database. So let's take a look at that. Actually, I'm going to get rid of this one that I think this is the one that get rid of that. So let's go back to CloudFormation. And here's our scripts that we've run to this point. So here's our PHP AMI build that we just did. So the next thing was create the infrastructure to host the PHP sites. Again, we're using cross-stack references. And if I hit the, one of the things I did do was I put out a page that shows the get info for the PHP. And if I hit this again, up in my right-hand corner, you'll see the instance ID. Let me refresh this. See it change? So it's load balancing across these 2 instances. So we confirm that. We've also mounted EFS. So that's going to be important when we go to install the content management system, because out of the box, the content management systems are normally stateful, and you have to do some configuration instead of using their inherent launch installation process, because they just don't work. So that's our environment. And we've got 2 running instances. The third instance that you see was the instance that was spun up as part of the building the AMI, which is now terminated. So those are the 2 instances that I'm hitting. All right. Okay. Config YAML. So we have alerts on our credit cards, and got an alert. My wife got an alert. And it was $500 and some. And she said, "What in the hell is this $500 charge?" I said, "I don't know." She said, "It's from Amazon." I said, "It is?" and so immediately, and so this is on my personal account, I log in, and I'm running these scripts, tearing down stacks, bringing stacks up, trying to get everything so that it's truly automated, one-step process, feed and input and output and all that. And sure enough, I look up AWS config. For every config rule, it's $2, right? $2. So I'm like, I got a dozen, 2 dozen config rules, $24. I can handle that for this demo. So I get the bill, and I look at the pie chart, and it's like all green, all the way except for a little tiny bit, and it's all AWS config charges. Every time you spin up a stack, you tear down a stack, or you make a change to a config rule, it's $2. So that is not clear in their documentation. So I did open a support case, and they waived it, by the way. But just be careful with config rules. Config rules allow automated compliance checks within your environment. It'll allow you to check to make sure that you have CloudTrail turned on, that you are using some certain tags. Let's take a look at some code real quick. And they've got a really good base set that you can use. So this checks to make sure all your instances are located in a VPC. It makes sure that all your EC2 volumes are in use. It checks the health check for the ELBs, make sure any elastic IPs are attached and not attached, because if they're not attached, you're charged for them. Your DB instances are backed up. Your Dynamo throughput limit is checked. I mean, just a ton of good out of the box. Here's the CloudTrail one. You want to make sure that's enabled. That it'll do out of the box. And so then what you can do is you can come over here to Systems Manager, and you can look at compliance. Oh, I'm sorry, wrong, not Systems Manager. We got to go to AWS Config and look at our compliance. So we have within our environment 28 non-compliant resources and 8 config rules that are being violated on that stack that I launched. Most of them are this one here. So this one is for Cloud Formation Stack notifications. So there's a rule that any time a Cloud Formation Stack is spun up, an SNS notification should be shut off. Whether or not I need that rule or not, I just thought it looked good on the demo. You can see green and red. So there's some others that are really important. Volume, CloudTrails 1, SSL on S3. I think there's one for public buckets it checks for, S3 logging, and so you can see all your resources. The other real nice thing about this is, let's go into the resources. Auto scaling, slip by tag. So there's an S3 bucket. Let's just look at this instance. Okay. Down here on the side here, there is managed instances. And here's AWS config. So if I click on that, every resource that you provision within AWS now has a configuration history. And you can drill into that configuration history and see exactly what's done at any given time by any given person and compare what that value was before and what it is after. So really powerful tool. Just be very, very careful with your config rules when you're tearing them up and tearing them down. So, any questions on that? That one's pretty cool. Pretty simple, but pretty cool. Very powerful. All right. Oh, one tip. So I didn't get a chance to do this. So the YAML file that creates the config rules, you have to subscribe to the config rules before you can use them. So what I did was I went into the GUI and I subscribed. But you can automate that whole process by creating a Lambda function and inputting the Lambda, the 3 parameters that it needs to subscribe, and then just execute the subscribe method, and then you don't even have to go to the console to do it, because it creates some policies and stuff for you behind the scenes. But you can automate that. I just didn't do it. All right, State Manager. This ensures that all your resources are always in a consistent state. And so this is another Systems Manager tool that we have that will run. So let's look what the YAML is real quick. State Manager. And I just have 3 real simple things. I want to make sure that all of my instances always have the most updated SSM agent. And that's actually a best practice by Amazon, by the way. I also want to make sure that Amazon Inspector is on this agent. That allows us to inspect it with security scans from Amazon. And then I also want to gather software inventory on it. And the software inventory is kind of cool. So you ask the question, I want to know if this certain package is installed. What do I do? So let's go back to our our Systems Manager console. And let's look at the inventory. So we want to do application and application name equal to, just off the top of my head, NTP. So we want to see where NTP is installed. It's installed on these 3 instances, and there's the agent version. So if you're looking for a particular vulnerable piece of software that you know has a 0 day, and you want to know what is my potential attack plane, you can go here and you can query directly, and you can do the same thing with Windows. So you can also run the commands. So this is kind of where it kind of feels clunky, but you start to get used to it after a while. You can run a shell script and just do a df-h. You can select the instances by manually selecting them or by a tag. I'll just select them all. Go ahead and run this. And then this should execute just as fast as it ran. And there's the output on there. So our disk space is 1% on 22. The mounts, the 2 mounts, yeah. So that's how you do your commands. So hopefully that answered your question.
Yeah, thanks.
Okay. All right. Maintenance windows. So this is pretty standard. Everybody has maintenance windows. For our organization, it's Sunday mornings. But you can define maintenance windows, and it basically consists of 3 things. A maintenance window, a maintenance target, which tells the maintenance window what resources to go after to apply maintenance to, which is done by tags, and then maintenance tasks, what you want to do within that maintenance window. So if I go back to my console, here's my maintenance window, and I've just called it demo maintenance. Within this window, I just set it on a cron expression, and this is GMT, so this is basically midnight. So it'll run this maintenance window every day at midnight. And the tasks that it will run, or first of all, the targets that it runs against is this right here. So it goes against any tags, any instances that have tags environment demo. And this is completely configurable. So you can define maintenance windows and targets all thousands of different ways. These are the tasks that are going to execute against that maintenance window. I've got a run command, I've got an automation script. So we're going to run a patch baseline, which is going to go out and do a scan to see where we are in our patch compliance on our Linux instances, and it'll give us a report, kind of like what we've seen with config, compliant, non-compliant. And then I'm also going to run an automation script, which is going to do that, basically that PHP file document, that automation document. My intent was to put the output of that in, because it'll run yum update and get all the latest packages and update the OS and all that, and then put that in parameter store and suck that into all the other scripts so that you don't even have to manage the latest AMIs. But that was the intent. So that's the maintenance windows. Any questions on that?
I'm assuming you can just subscribe to alerts for failure or being success.
SNS, yeah. Yep, SNS, and you can route them to queues, you can route them to emails, however you want. You can actually route them to your ticketing system too, which is what we're going to be doing next. So, Patch Manager, we touched on this. So Patch Manager allows you to create patch baselines based upon, and I'll just show you the code on this one. It's not real exciting. OS Patch Manager, this is a task on the maintenance cycle. So what it does is it creates a maintenance window task, and it creates a patch baseline. Here we go. Here's the patch baseline. So what it's saying is for operating systems, Amazon Linux, that's in patch group prod, apply any classification level of security that have severity of critical and important, and these are deemed by the vendor. So the vendor will specify these patch compliance levels. You don't have to worry about that. Apply them after 3 days on production. You could also have a patch baseline that says after 0 days, apply them on non-prod so that you're testing them before you actually apply to prod. There are some shops that just like pushing this out manually. You can also build an approval process to do that and do the manual push. So Any questions on that? All right.
In your methodology, I didn't notice, Jim, do you guys patch the base image?
We do. So we start with the base image, we patch the base image until the new image is released. Once the new image is released, we run our automation scripts to rebuild that again.
And you don't release a new image every day, for example?
No, we do not. We do not. Automation AMI. We kind of talked quite a bit about this. Another maintenance task. This is where you can create your AMIs, do all your patching, put it into parameter store, and then the next time you can schedule, you can actually invoke your auto-scaling groups to pick up the latest AMI from parameter store and then spin up during your patch window. You can do that as well. So that's all this task does. So it's just an example of doing the patching on an automated process, taking the snapshot, important when the instance is not running due to security, and then putting that into parameter store and then using that as the latest AMI for that region. Where it gets really tricky is when you try and create cloud formation scripts for different regions, even availability zones, because the AMIs, they are different for each region, right? So if you want to have a machine that's running the same version, you have to keep two different parameter stores, one for the east region and one for the west region, and then when your CloudFormation script runs, you use the intrinsic functions to determine what region that CloudFormation script is running in, and then grab the AMI that's specified in the parameter store by the region that you've stated within the key. Does that make sense? Okay. Any questions on that?
And I think you've touched on this. All your examples are pretty much just all Linux-based. Is that right? Not really touching on Windows here.
They have way more support in Systems Manager for Linux or for Windows. I primarily work with Linux. I was going to try and get a Windows box spun up. I didn't. But you can specify whitelisted patches, blacklisted patches, and they're all the KD numbers and what you approve. And they've actually got, I believe, more support in Systems Manager for Windows than they do Linux. Inspector. So this is the automated security scans. And AWS has four rules packages. We mentioned them before. They're right here. And this allows you to run automated scans against your environment. And so if I go into Inspector, I have a CloudFormation script that configures the environment. And you see I have a recent run, and I have 10 findings, 1 assessment run completed. And if I drill into this, I can download the report. You can view the findings. I thought there was a quick way to see them, but let me download the report. Findings report, HTML. There they are. I knew they were somewhere. All right. So we have within our environment 2 medium severities. And it is because the security best practices tells us, what does it say? Runtime analysis. Oh, so our servers are configured to allow login with root credentials over SSH. Best practices, you shouldn't allow that. So you should disable root credentials and create an administrator account. So that's Inspector. Very cheap compared to some of the vulnerability and scans that you have out there in the market, in the proprietary market. And it does a really good job. And what you can do is you can actually set up lambdas so that when you hit a certain severity level to trigger a notification that will auto-patch it. And that's in the AWS Labs GitHub repo. It's auto-patching based upon Inspector findings. So if it finds a critical security, send a notification out to Lambda. Lambda will go out, get the CVE, find the patch for it, and apply it immediately to your instances. Pretty cool.
These best practices are given by AWS, or you can define the of?
The patch rules are defined by AWS. Yes, they're package sets. Yeah. A good question though. All right, almost done. Guard duty, and I mentioned before. So this is really new. We're just trying it out. I don't have a ton to demo on this. Let's go into the console because I haven't looked at it since the 2 days ago I provisioned this environment. Let's see if we've got anything. I can type. Don't have any findings. Okay. So we're playing with it. Don't know much about it. Check it out. That's kind of why I showed it here. Don't know if you knew it's in a 30-day free trial. I know I mentioned that. Pretty soon they'll probably be charging for it. So we're trying to hook you first, though. Almost done, guys. So the last piece, deploying code. So we use AWS Code Deploy. Our development pipeline is all based upon Jenkins. Our Jenkins continuous integration process pushes all of our source code to those 2 buckets that we created in the very beginning. And then we use AWS Code Deploy. Jenkins has plugins for Beanstalk, Code Deploy, Lambda, just about anything. I mean, Jenkins is kind of like Swiss Army knife, right? If you're a developer, you know what I'm talking about. So once the commit is checked into our Git repo, Jenkins detects it, kicks off our build development. We're talking application level builds. Runs all our unit tests, runs all of our systems tests. If we have performance tests in there, it does all that. After everything passes, then it invokes the plugin to deploy it out to S3. Once it gets deployed out to S3, the plugin then will invoke Code Deploy to deploy it to the target environment that you want. And so what Code Deploy looks like is like this. So you create an application, and for our application I gave it Joomla, and then you create deployment groups. And deployment groups, usually what we do is we equate those to environments, right? So we have a deployment prod group, deployment staging group, deployment dev group. Demo is what I created here. And then what you can do is every time you upload a revision through Jenkins, it gets copied here, and then you can deploy that revision through the console. You don't have to do it. Ours is all automated, but I'll show you how to deploy it through the console. So we'll pick the demo group, and you can roll back. Now they have different, this is what's really neat about Code Deploy, is they have different deployment lifecycle rules. So you can do scheduled deployments, you can do rolling deployments that says roll out to 50% of my instances. When they're healthy, then roll out to the next 50%. You can do blue-green deployments. You can do deployments where you spin up all the instances, you check to make sure they're all healthy, and then Code Deploy terminates all the old ones. What this one is doing is just that. So it's gonna deploy the application out to the instances. In fact, I don't think it's doing that. It's just going to deploy it to the instances. Now it runs, let me look at the events, several steps. And in order to use Code Deploy, there's 2 things that you have to do. You have to install the agent on your instance. This works with Windows and Linux. And you have to also define another YAML file. It's called an AppSpec YAML file. That AppSpec YAML file basically tells Code Deploy what to do with your code once it's uploaded to the S3 bucket. And so I have an AppSpec file packaged within that zip file that says, for these files, deploy them to var www/html directory. So basically to my Apache root. And once it does that, there it goes, it succeeded. Once it does that, then it'll proceed to the next instance. And so now it's deploying to the next instance. And this is the, I talked about that Joomla zip file that was the complete install. So if I go back to CloudFormation, and go back to our web infrastructure, what you'll see now on the outputs, I still have the info page, but if I hit this page, there's Joomla. We just deployed it, through code deploy. And this is the installation process for Joomla. Now this will not work in a clustered environment. Out of the box, Joomla installs are not built for clustering. What would happen, since we're just running off EBS volumes for this, because we just deployed the code to an EBS volume, I'll go ahead and I'll fill this information out. Hit next. Hopefully, not now. And it's not going to do anything. Now it's telling me a security token is. Because remember when I showed you in the beginning on the info page, it was swapping back and forth to instances? This is trying to save state on the installation. And that's where you talk about, when I talked about cloud ready versus cloud native, you really have to know and work in conjunction with your development team when you're on the operations side in order to be able to deploy this stuff out and be cloud safe. So what I did do is put this out on EFS. Not RFS. Oops. So EFS is network attached storage. So now instead of the instance that gets the request is serving this page, both instances are sharing the code for this page. So now this installation, while improved, is still, let's see, going to have a problem, and I'll tell you why here in a second. So we'll get to the next page. Not now. Yeah. So what Joomla does in the background, and I did completely disagree with what they do, but they have a security check on their installation that makes you go through some additional hoops if your database isn't stored on the same instance as your web server. Some security thing some guy dreamt up, but it really should be separate. So they've got checks in there, and so in order to configure this, we need to do some Linux scripting for the configuration file so that it's cloud ready, and then it would be deployed out. So, all right, guys, we're almost done. Sorry. All right. So the fictitious business requirements. Know your company's technical inventory. We've seen that with the inventory, the software inventory gathering. We've seen that with the service catalog. We've seen it with config rules. Cost transparency. I can't emphasize tagging enough. Make sure your tags are consistent. We've increased our customer value delivery because we're using services and not managing all these servers. We've improved our security compliance and auditing and logging, prod, non-prod parity, so we can spin these stacks up, drop them, spin them up, and they're going to be the same as what prod is running. Use services and automation to reduce maintenance and errors, and so how do you manage your growing footprint? Automate. What's new? This is it, guys. So this is exciting because some of these things were recently announced at reInvent. CloudFormation stack sets is the ability to deploy stacks across multiple regions in one step. Today, you have to go to your CloudFormation template, deploy it to the East 1, deploy it to the East 2, deploy it to the West 1, deploy it to the West 2. With stack sets, you can deploy globally, and it's in a one-time shot. And you watch the progress, and it's all done asynchronously. So you know your global infrastructure is all running the same stack. Really cool feature. Actually, it's right there. That's the information. Great for business continuity, disaster recovery. Great use case. Auto scaling. So another new feature. Wasn't announced at reInvent, but it was announced this January. AWS no longer requires you to create alarms and thresholds to do your scaling. It takes care of that for you. And in order to do that, and that's for Dynamo, that's for your auto scaling EC2 groups or ECS containers. In order for you to do that, you have to use CloudFormation. It will not work with anything else at this moment. Really cool. Dynamo or Aurora replicas as well. So this is the most exciting for me. And so drift. What's drift? There's always cases, production instances down. You don't want to have to go through that big long process that I showed you to update a template, make a change, deploy it out. So you just get on the console and fix it because your customers are screaming at you. But when that happens, you make those changes out of band. And at that point, what's running in production doesn't match your template. And those are very difficult things to catch. Usually, the person that catches it is the next person that's going to apply that stack to that production environment. And they're going to go, what in the world just changed? Do I go ahead or do I contact whoever ran the last thing? So what they have is they're going to, it's not out yet, they're going to have within CloudFormation a area on the console that shows the drift status. And it'll tell you if the drift is in compliance or not in compliance. So some of the side effects, if you're not careful with drift, is your stack operations can fail. You can get the stack to a state where you can't delete it or even update it, and I ran into that this weekend. It's a divergence from your approved architecture. So really, people making these out-of-band changes should be really privileged employees and staff. You shouldn't just grant it to everybody. Least privilege principle, right? And then unaccounted changes are not in your source code. So what it looks like, this is what they showed, is they're going to have a drift status, not drifted, drifted, not checked. And then if it is, and I don't have all the slides, there's resources in the end of this presentation that has the YouTube video on advanced CloudFormation. It's worth watching just for this. There's like 8 slides that they cover drift detection and how they're going to handle it up and coming this first quarter is when they said. So with that, I thank you. You guys have been a great audience. Thank you for giving me the opportunity to speak here, Chris. Anybody from Object Partners, again, thank you for the room. And if you have any questions, I'm open for questions.
Thank you, Brian. Oh, do we have questions?
Jim, I was just going to say that this had to be an enormous amount of work, and to do this for the benefit of this audience is fabulous. So thank you very much.
Yeah, a lot of late nights over 1 week. Trust me, my wife let me know. Yes, Kevin.
Jim, so I get a lot of questions about Aurora. And you mentioned you guys are using Aurora. Can you just talk briefly about kind of what your experience has been with Aurora?
Okay, so Aurora is Amazon's port of basically MySQL. They got a MySQL and they have a Postgres database. And it is a fully managed Amazon RDS instance. The benefits of using Aurora is it's cloud enabled because they built it. So one of the things that you're starting to see now is cross-region replication with Aurora. And that's not possible with standard RDS without going through a lot of hoops. And that really is powerful when you're trying to do maybe hot DR, or maybe you're deploying your infrastructure globally. Aurora is also going to be moving to a serverless technology, which I'm really pumped about, because you're only going to pay for what you use. You know, the concept of serverless. Right now they have read replication across regions, but it is Amazon's port of MySQL and Postgres optimized for the cloud. Great product, and it's about 10 times faster. We've used both. So.
How about DynamoDB? I just saw a brief mention about checking it for the CIDR addresses. Apart from this, you guys extensive use of the DynamoDB?
Yeah, we're using Dynamo more and more. So when I talked about one of the big usages, and it's not really for an application per se as a data store, but we use it for our Java stack to manage session state in order to make our Java applications that are legacy cloud safe. Because what you can do is you can put the session into DynamoDB, and that's a great use case for it. And so now when we spin up instances and we're running a Java application and those instances come down, we're not knocking users off. So the big thing that I was trying to implement was to be able to, we used to have these maintenance cycles where we had to deploy code like at 10 at night, 2 in the morning, and guess who was doing it? Me, Bhaskar, and Ali, right? And so I said, no more. We want to make an environment that we can deploy in the middle of the day without disrupting the customer. And that's kind of what AWS gives you. And we use Dynamo for that on the Java side. The PHP side, I didn't talk about Redis. We use Redis to store session state for PHP, so we can bring PHP applications up and down. Users don't even notice. We can deploy it at any time. So if it's cloud native, you don't have to worry about it. But it's these legacy applications that you're trying to get to the cloud, take advantage of the cloud by horizontally scaling.
Like you talk about Aurora, how big is the database that you're using in Aurora? It's a medium size or large size?
Oh, I don't know that question off the top of my head. I want to say it's a large, but I don't know what size we're using. I can tell you we have close to 100 sites on it, 100 databases on it. So, yes, sir.
Hey, I was late on art to publish the presentation.
What's that?
Will you?
Oh, post it? Yes. Yes, so the slides are posted on the meetup group.
All right.
And then let me jump back. You guys can write this down.
I have a link on the
Yeah,
description.
he has another on the invite.
All right.
There's my contact information if you want to get a hold of me. My GitHub repo location that's got the code, and then the meetup's got the slides.
Jim and DJ, I'm curious, so this is obviously, you guys are an advanced shop for AWS. It's part of the reason everybody wanted to have you here and talk. How is the adoption of cloud going in the team inside of .com? Is everybody embracing it to the degree that you guys are? Is the dev team all in?
It is. I mean, we started our journey like almost three and a half years ago. I mean, what you're seeing is the result of 3 years. 3 years back, we had sites, we have close to 200 sites, each running on different version, a different flavor, different OS. We had malware every day. We got sick of that. So this is the 3 years work. I mean, we've matured so much. And earlier we had, just 1 or 2 resources. Now we've added 3, 4. You mentioned Ali. We have Bhaskar. We have Jim. We have some offshore resources we utilize. So the adoption is pretty good. They're learning. They're getting up to speed. So it's a hard journey, and it's a lot of training and and a lot of hands-on experience. So.
Yeah. I will say on the ops side, when we started our journey, and it's probably the same in any other shop, the operations guys are like, we're taking our jobs. And no, we're not. I mean, we work closely with the operations team. They're starting to have some use cases, and they're actually coming to us for solutions, which just makes a point of how far we've come with AWS. The things that we've done that I showed today was a direct response to some of the feedback that I had from our ops folks, because they're like, this is too complicated with this Terraform stuff, this Chef stuff. I mean, I got to know Ruby, but they know PowerShell, they know SSH, I mean, they know Bash. So let's use the tools, and it's easier to find resources. And so we kind of took it down a level because we were, I think, getting to the point where we were very intimidating. And I didn't want to be that way. I wanted to feel like you can use your tools and still play in the AWS environment with us.
You said one of the components, I think I heard you say, is making all the tools that you use inside the platform as much as possible. So
Yes.
use AWS tools
Correct.
wherever possible, and you
Correct.
find better adoption for the ops guys.
Yeah.
Yep.
Yeah. Absolutely. Because then they're not having to go to this open source library, this open source library. I mean, there's great tools out there.
Yep.
I mean, we've looked at them. Terraform's a great tool. Packer's a good tool. Troposphere. I mean, there's lots of good tools. It's just how much technology are you willing to ingest? We are a small shop. I think we have maybe 80 total employees at .com,
Correct.
and I think 40 of them are managers. but so we can't overwhelm them with tools, right? So we've got to kind of leverage what skills they have.
And this was the best fit for,
Yes.
I mean, using within the same stack was probably that works well for us.